My name, as was said, is Hodler. I anything network science and graphs. Work at Relational Native Knowledge Graph. We just recently out of stealth mode, and also just recently won a vendor award. So a lot of exciting stuff going on there. And I want to start with something that I suspect most of you have said, and it's certainly most everyone have heard. If I get a result, prediction, but it is you actually have more data than you realize. You have more predictive data than you realize. It's just the ability to get at that and use it. And so if we think about how we build better models, we all pretty much know how to build a better model. You either improve your data or you encode some kind of expertise or knowledge into the system that you're creating. And if you're looking at data, that's squarely in data-centric AI, looking at improving the quality, having higher quality data, more accurate, just more if it's good data as well. But to encode knowledge, that's something we actually already do a lot of. You think about data cleansing, data sampling. If you're telling a system what is going to be predictive or what it should be learning on, you are encoding some kind of knowledge that you have. And then there's more advanced types as well. So if we're looking at feature engineering or weak supervision, those are ways that in a more advanced way, we're also encoding knowledge in some fashion. So lots of different ways that it can improve data and encode knowledge. And unfortunately, the first do when we start building a predictive model is to steamroll our poor raw data. So we basically, the first step we do when we're looking at creating features is we flatten our structures. And if you think about all of your organizational information, how things are related, what are the dependencies? What's the importance of this item? What's the structure of how things are dependent upon each other? That's valuable information that a business expertise would know. And we cram that down into a feature matrix and lose a lot of that information. And we do that because we have to. Machine learning systems don't handle highly dimensional and very complex data so well. So we have to do it, but we're losing good data right out of the gate. And we also happen to toss out relationships. And so when we create a feature matrix, we assume entities are independent of each other. And in the real world, there isn't much that is independent of each other. Things are very related. If you think about predicting, let's say, what kind of bicycle components or bicycle services somebody may want, that's highly related to what kind of bike frame they bought. It's highly related to whether they're a high-end consumer, and the different services they may want are very related items. And so throwing out that type of information kind of degrades what we can do. And you might say, hey, Amy, that's just a little bit of information. It's not the important part. It's not the frame, but it is important. So in machine learning, we're trying to build a model, learn off a model of the real world. And if we create stripped down models of the real world, very shallow models, we are stripping away this knowledge, and we can't take our as far. We can't have that if we might otherwise. So the first thing to do is don't actually can improve the quality. So incorporate lots of it out there, but the structure, we're not capturing business logic, and we need to do that in our models. We need to look at other technologies or other areas like image and text, and be able to relationally organize data. And relationships themselves, we know based on multiple studies, got a couple books here that I just love, highly recommend, studies that show how are very predictive of behavior, relation predictive of behavior. Graph-based structure, engineer features, is one of the lowest hanging fruits you can take advantage of to improve your models. So the other thing we want to do is, if we are encoding knowledge in any fashion, let's not waste it. So you're hearing a lot of talk recently about semantic models and semantic layers, kind of an old term that has a new twist now. People are looking at how do I map data to the business meaning and the importance of it. And they're looking at that as a way to help us streamline development of things like data apps. So how do we gather that intelligence and gather that that logic in a way that we can make our data apps more intelligent and do it in a way that we can streamline some of the pipelining that would normally go on. And if you happen to be capturing this kind of information, and I hope you are, how do you then use it in kind of a machine learning context? Well, you can use a knowledge graph to feed that kind of predictive data and that knowledge into a platform like Snorkel. So a relational knowledge graph very simply models business concepts with their relationships and their associated logic in kind of an executable way. A quick example here of how that can be used is a graphic from a Google case study using a Snorkel dry bell solution is what they called it. And they were using a knowledge graph as organizational information and organizational resources. But if you add in a relational knowledge graph, you can not only grab those relationships and the dependencies, but you can, because of the logic, you can also add in heuristics, business rules, business logic, as well as semantic information as well. So what we're trying to do with relational AI is to be a pairing to the modern data stack so that you can bring together all of that rich corporate data that you have with knowledge as well, bring that together, drive more intelligence into more intelligent data apps, build, streamline that development, but also support more complex workloads that don't traditionally do well in a relational database like graph analytics, reasoning, and optimization workloads. So if that sounds interesting to you, please reach out, say hello. I love to talk about this topic. And if you're interested in a relational knowledge graph, go to relational.ai, and you can sign up for early notifications, early access to the product. So thank you all for your attention, and please feel free to say hello.